All right, so hi, my name is Nick. Some of the slides, I chose some unfortunate color schemes. So if you want to follow along, they are posted right now. So I'll just give you a moment or two. It might be a touch easier to read. And I'll post that link at the end as well. Give people a minute here. All right, the vault door is closed. That's it. You got me. I have you for an hour. So I originally gave a version of this talk in Los Angeles a few months back at the B-Sides. Really great group. Daniel Blanchard hooked this up. 3 blocks away from the conference, this was the view. And I know it's OWASP and everything like that, but one thing that's really interesting about these sort of local groups is, at least in the Los Angeles one, 1/3 of the group are invited speakers outside the area. And it turns out that's really good, because it turns out Los Angeles is a really different industry than New York. Turns out film companies have security problems, defense industries have security problems, but they're kind of different than the ones I deal with in sort of like web development type stuff. So pick a city you're interested in visiting and go talk to the B-Sides guys there about presenting. I think you'll find it really, really interesting. Anyway, so I got a bunch of photos here. I took all these, unless I didn't, in which case they're from the internet. So continuous deployment, rebooting software development. And people are like, oh, really? And for some reason, the word DevOps is sort of a hot button topic here this week. I don't really know why. So let's finally a little bit about me. That is a ridiculous photo that someone took. That's a whole other story there. I used to be the director of engineering at Etsy. I built the security groups, fraud groups, email infrastructure groups, analytics groups, and I'm probably forgetting a couple there. So I'm on a new gig, but I'm very good terms with Etsy, and Zane can attest to that. And I'm at a new company in a different space altogether. I'm relocating to Tokyo. I'm not quite ready to announce it yet, but that's coming up. Anyway, that's sort of irrelevant for here. Important thing is my background. I didn't sort of start in security. I sort of ended in security. My background is software development, web-facing companies, lots of high scale, databases to UI, to C, to PHP. And so my background is very much based from a developer perspective in web applications. If you're doing embedded systems, if you're doing defense industry, safety engineering, different risk profile, different stuff. Your mileage may vary. OK. So web app vulnerabilities realistically are not a very complicated vulnerability to understand. SQL injection, parameterize your queries, more or less. It's almost all of them are validate your input. Yet, as a security industry, we're not getting ahead too far. The group, the presentation before me, I hope you saw it from the Twitter, like utterly fantastic on sort of like automating and finding web vulnerabilities. But at the end of the day, web vulnerabilities aren't that complicated. They're really not. And so how can we ever really sort of get ahead of the game? How can we really sort of move, from this, we're constantly trying to like bat down the bugs and stuff like that to actually changing things. So I spent a lot of time like figuring out like, how did we get here? And this is the view. I don't know about your view, but this is what my view looks like. It's not so cute. So how can we get ahead of this? How can we do this? And how did we end up here? And we spent probably about 10 years like trying to figure out SQL injection. It's still like #1, OWASP top 10, #1 injection vulnerabilities. So what are we going to do? And I've been sort of doing a lot of thinking on sort of like how software works, how it's built, and I posit sort of the software product model is still sort of like the dominating sort of theme in software development, even though it might not apply anymore. And code, whatever your sort of methodology is, code flows between functional groups. It might happen quickly, might happen slowly, but it flows through functional groups. Product managers spec code, engineers write code, QA guys test code, security guys test code, release engineers package it up, and operations guys run the code. And that's not a bad model, but in my mind, it was designed for when software distribution costs were really high. So, and high might mean risk, continuous deployment in certain financial applications, maybe not perfect. money, time, resources, customer annoyance, whatever it is, it's designed for like really high-risk environments, which certainly would apply to like things that are packaged goods. You had to burn a CD disk and put it on a truck in order to recognize revenue. You really have to be careful that your final product is good. And actually, I lived through that. It's like there are things like we had to ship empty boxes on a truck with a coupon in it because we're a public company, and that's how we were able to recognize revenue because the CDs were late. I mean, it's like when you have a really high risk of failure where there's real impact, this model works well. Obviously, same thing for embedded systems, front load. Operating systems, real pain in the ass to update. And your homework, which is how we've all been trained if we went to computer science school. Your homework's one-time deploy. Hand your homework in, that's it, better be right. So I think we've all been sort of trained by this model. And this is, for many applications and many companies I've worked at, this is sort of what it looks like. Specs come in, huge pig pile, people writing code constantly, maybe they're checking it in, maybe they're not. And at some point, this sort of dies down, and we got sort of like bugs, fix, slush, all this stuff, and the QA process sort of winds down, goes to release, and out it goes. Could be weeks, months, all this other stuff. So the impact on production is sort of like this. You got, if things are quiet, there's this release of all this stuff. Changes happen. Maybe there's a little minor release here and there, and the same thing happens again. And the new features going live is exactly the same as number of changes going to production. Lots of code change equals new features. So nothing wrong with that. That was in the subway one day. I had to take a photo. I was like, wow, what are the odds of these two people standing next to each other, and what will happen when they get off the train, right? So, given high distribution costs, that model might be the only way you can do stuff. That's cool. The problem is, and web applications, year 2000, so that was, oh my, 12 years ago, pretty much that's all we knew. Really high barrier to entry. The web was new. Specialized hardware, software, people get started. Oh yeah, the new Sun box, $50,000 bucks. VC fund. You couldn't launch a web application without like VC money. It's just too expensive. Now it's like, why not? Why not launch a web app? So lots of engineering to get things going. We just didn't really know what we were doing. And this is a true story of what an actual sort of software product model was at a real company that's still around today. But when we were pre-launch, marketing guys are going mental. It's like, we got to fix these spelling errors. The guy's like, CTO is like, no way. I've seen cut and paste errors happen. If you want to change a spelling error, here's our feature list. Go sort it and however you want, and we'll work down that way. So it's like, spelling error is not changed for like months because it's just ridiculous. Like people are just too nervous about the QA cost. And releasing code is such a nightmare that it's like, no chance we're going to risk it. That just doesn't sound right for the web. Just doesn't seem right. So, and like now, let's zoom forward to today, there's almost no barrier to entry, like literally almost none. Like I don't even know if you need a credit card to launch things on EC2. Certainly it's free for a small amount of time. Hardware is super commodity. I can't remember the country it's in, but this happened like a week or two. It might have been like Ukraine. Programming, let's teach it to everyone in elementary school. Like, if you're not learning to program in security now, it's like, get on it because you're going to get whooped very soon. Scaling problems can be outsourced, more or less. Like, the barrier to entry is super low. So when you're distributing like web applications, what's the actual expense? You're moving maybe a few K, a megabyte from your dev box to your production box. It's like free. It's like there's 20 million ways of moving your code from dev to production. It's completely free. Distributing code versus making a new CD-ROM, doing an OS update, totally free. So given sort of the new world we're in, it makes sense that we can do something a little better than the software product model. We all sort of like started there, And there's an enormous number of organizations which have codified political structures around that. And it makes sense given where we came from. Web's still fairly new. But unlike sort of retail applications and a lot of this other stuff, web applications really have a different way of failing than some of the other ones as well. And the nature of this failure is like, web applications are data-driven. They're not CD-ROM desktop apps. They're really data-driven. I mean by that, there's data flowing into the application to like render stuff, and there's data flowing in, like user input coming in. Stuff from the database might be 5 years old, 2 years old, 6 weeks old. You never know what's actually coming out. There's been changes, schema changes. Old stuff came in a long time ago. Maybe it's in the wrong format. And certainly users are doing things in most unusual ways. And we like it. We got APIs. We got user-generated content. We like mashing stuff up. People are using your site in different ways than we could ever expect. So really, failure cases, and I mean failure could mean stability problems, certainly security problems. Not really likely algorithm, but it's like bad input coming in or bad input coming up from your own database. And as I said, data in the past might haunt you later. So let's say you had a security problem, cross-site scripting or whatever you'd like. Your database might be corrupted, but it might be years before you start rereading that data again. That data's sitting in there. Unless you're sterilizing your like terabytes of data floating around, which you will never have time to do, you don't even know what's coming back out. It's really complicated. But anyway, in terms of releases, when you got a release, when it happens, and this is note to self, black on colored text, not good. When it happens, you do your big release, you got code from a half dozen people, a few bug fixes, security thing, maybe a couple new features, and I don't know about you, but I've lived through the rollback way too many times. You have to push, it goes out, something's wrong. You cut a branch. Can't say like, oh, let's just roll back half the branch. What would you roll back? What the code is? All you know is the site's sucking or a security problem, and it's like you have to undo the whole thing. And the next week or 2 or 3 is sort of like doing some binary search, trying to figure out what the bug is, fixing that, re-QAing, re-pushing, and while this is going on, there's new code piling up. Ugh, it's like weeks. I've lived this. Actually, this happened to me just the other day because I'm working on a new project, and the guys were like, hey, this doesn't run in 64 bits. Like, okay, I'm going to go through, add a bunch of casts, all this other stuff, great, commit, but go forward. Oh, it doesn't work. I just changed 20 files, and now I have to like bisect all my changes and figure out which one broke. Huge waste of time. And that's basically how we roll in Web 2012. Okay, so software product model in Web App 2012, there's a long time, as you can read here, between code written to code deployed. Okay, this means all these non-value-added steps in the middle are in the middle there of someone writing code and getting it out. Might be weeks or months before code is deployed. How many people are in organizations where it is a week for a developer to get code in production? 1, 2, 3, 4, 5, 6, 6. You think they give a crap what happens after that week? I mean, a week's good, actually. A week's pretty good. Month? Work at a bank? 3 months? They have no idea even what they wrote. The engineers on a different product by now. They're gone. They're mentally, there's no feedback loop for them at all anymore, none. And is it any wonder engineers aren't interested that much in operations or security when there's no feedback loop for them? It's like if you just work in psychology, it's like if you had to hand your homework in, you get it back a month later, would you really care what the result is anymore? You've moved on. So the other sort of big hypothesis in these like huge data-driven sites, that at least I seem to be stuck working on in my career, it's also near impossible simulating production environment in development. Very few people are brave enough to have a complete mirror of their production database in development. Might not even make sense for security reasons as well. So there's really no amount of testing you can do in dev that actually correctly simulates production. Data is not the same coming out of your database. Likely, I've worked very hard at making development near the same as production, but it's always a little different. Domain's different, so your cookies are a little different. Weird interactions between dev and prod, all sorts of stuff. And we know after how long we've all been doing this, after all these different software development life cycles, everything, we know you have bugs and vulnerabilities on whatever project you have right now. In spite of all the stuff going on, it already is there. So, not to say that QA and testing isn't important. It absolutely is. I'm saying in spite of all our best efforts, it exists anyway. These problems exist anyway. Right? So you're screwed, right? You're done, right? There's nothing you can do. Company wants to push faster. Being a bottleneck, saying no isn't acceptable. You can't, asking for more resources, like, yeah, maybe hey, good for you if you ask for it. A lot of security groups don't even ask for it. Engineers are disengaged, and you know there's going to be a security problem, or replace operational problem, or stability problem, or QA problem, or whatever you want to replace it with. And whack-a-mole, this doesn't scale. Just doesn't work. So my hypothesis is if we want to fix security and get ahead of the game, we, as security professionals, have to fix development. Tall order, maybe. And so my answer is, you know what the next slide is, hey, continuous deployment solves everything. That doesn't solve everything, but it gets us closer, I think. And it's certainly for web applications a step forward. So I just made up this definition. I'm turning into the poster boy for continuous deployment, but I don't know. So system of software production characterized by small, infrequent changes, as opposed to sort of the big bang cycles. And it's that crazy stuff Etsy does. You know, we all talk like, oh yeah, we do 30 deploys a day, you know, whatever. Google does it, Facebook does it, Amazon does it, Twitter does it, and a bunch of other companies do it. So even if you think it's nuts, you have to sort of acknowledge that successful companies are doing it. Okay. So in a continuous deployment model, here's how the feature deployment looks. New features roll out, but the amount of code that changes for that feature isn't correlated anymore. The new feature got launched with only a tiny bit of code. Like, huh? It's because we pushed out all the pieces of it previously. And we know that these paths have already been through our automated testing, regression cycles. You know, if you're doing C applications or Java applications, you at least know it compiled and it's not exploding the site. And we'll talk a little bit more about this in just a sec here. Okay. So the goal of this is, and this doesn't really make sense for this thing, but I select the picture because it just happened the other day. You know, the goal is to have developers responsible and confident in their code in production. And I can't say, you know, in a lot of places I've been, most of the time they don't even care. They don't even know how it works at all. So it's like, hey, I wrote code. I'm done. I'd say that is characteristic of a developer, not an engineer. You know? And so what I really am trying to do is force developers to become engineers. So how do we get there? How does this work? And what does it do? So I sort of did a slightly platonic dialogue with this. And the exact number of mechanisms is honestly probably another hour talk. Probably know where to go to it in a security session, but we'll see what happens. So here's how you roll this out. Here's how you change culture and how you change sort of like developers to basically caring about what you do. And this is funny. So what if you had a big button that said deploy, and anyone could push it, and everything on whatever source control you have flows to production. Whatever it is, of course it's logged. Of course, you know, there's basic sort of sanity to it, but basically anyone go to the button, out it goes. If you don't like deploy, think of sort of like maybe non-supercritical production boxes and say, what if we gave everyone sudo? Maybe that's maybe an easier sort of mechanism. Like I saw one guy roll his eyes like, holy crap, don't do that. But just bear with me, if you would. Right? So it takes about a minute. It's not very long to do. However, whatever system you have, a minute, it's out. So here's what happens. It's certainly for more junior developers. Oh, no, I'm not doing that. No way. That's crazy. Which exactly sort of indicates the problem, right? And we got new hires, and I'm not at Etsy now, but I'll give you an example. New hires, first day, like, oh, no, no. I'm not pushing out code. I don't want to break Etsy. I'm not going to be that person who broke Etsy. Like, it's not that special, but OK, yeah. We can fix it. It's all right. But like, they're terrified. And anyway, so back to my analogy. No one's touching it, but yet everyone's still writing code. OK. So at some point, some obnoxious person is going to say, I'm doing it. All right, let's go. Let's do it. I'm tired. And what's interesting is someone else is going to tell them their code broke something. They're not going to hear it. They're not going to see it. Someone else is going to tell them that their code broke something. Nice thing is at least a person told them. And it was due to immediate reaction. Like, hey, this feature just stopped working. Why'd you push that out? Oh, like, OK, that's better. It's certainly better. So we really don't want someone else to tell them. And actually, I'll tell you, my current gig right now, not nearly as, it's like rolling backwards in time from Etsy, which is an interesting challenge. Literally, it's operations and dev, and what happens is a release goes out, and operations sees something in some log, and then they file a ticket, and then like the guy in development reads the ticket, and then it goes, you can just see this backwards and forth, like the amount of wasted energy just flowing back and forth from development to operations, development to operations. OK, so how can we get this improved more? All right? So developer learns, they actually don't know how code writes, how their code works in production. So certainly exposing the logs to them, huge step forward. They can actually see if they push the button, whoa, the log, the error logs just exploded. Like just a sheer velocity of like errors happening. And if you've done development or production, it's like, oh, I forgot to initialize a variable, and like meanwhile now you have like megabytes of log entries per second flying out at you. Oh, OK, I broke something. More interesting would be like something like Graphite, Ganglia, StatsD. There's lots of things there where if the developer can easily instrument their code so they can see what happened. The Graphite, Ganglia, StatsD thing, you get this, read the link, read the blog article. However you want to do it, it's fine. I know lots of people who sort of like have things that poll the site and like insert things once a minute. There's lots of ways of doing it. But what you want to do is make it really easy for developers to instrument their code and make a graph. I should have done some picture here. Make it free to monitor anything in the application and expose that to everyone. So it could be, hey, I'm changing auth. Hey, let's just see, why don't we just measure how many logins per second happened? If I push a change and it goes to 0, guess what? I broke something, right? Oh, and this happens all the time. You test in dev, it goes to production, doesn't work. OK, so I mean, QA is good, but seeing a graph drop to 0 of logins, that's even better. Having that visibility is really important. OK, so let's back to our hypothetical developer. They have some graphs. They're going to repush, and here it is. They push something, graph craters. But this time, at least the developer was aware of what is happening. They're able to self-service their own problem and then roll back. Okay. Next step is really isolation. And this is, developer, when they're reviewing code, they're pushing, they just realized they just hit the button and everything on trunk went out. And they look back and go, oh, I'm pushing out some bug fixes. I got my stuff. The other dude down the hall pushed out something. Hey, maybe just pushing out a single bug fix will just, at least then I fixed a bug. Let's just get that code out, and we've just made the world just maybe a touch better. So my hypothetical situation, yeah. And that's the secret. It's pushing out really small things you can understand. And you can understand because it's, they're small. That's why you can understand it. Like do like the SVN diff or git diff between two of your branches, and if you're doing the old thing, it's like, it's like 30, 40, 50, 60 pages of like diffs. Like no one actually is interested in code reviewing that. It turns out. Like, no one wants to like, hey, that's cool. I'm going to do nothing today except review code for everyone else. Like no one does that. If they say they do that, what happens is like, oh yeah, you know what? There should be a space between the commas here. Like they just pick like trivia because it's easy. Understanding what 20 of your colleagues is doing is really hard. It's really tough. So anyway, that's sort of the secret. But then, what if you want to do something bigger than just a bug fix, right? How do you get those out? So the hypothetical feature this developer is getting out, he still can't quite figure out what's going on. Got some bugs out of the way, but his change might be 20, it might be like 3 new files, some new functions scattered around. Let's just push those supporting files out. Just get them out of the way. Just push out these files that they're not being actually used in production. If you have compilers, they might actually get compiled out in the final executable. If you're doing like PHP or something like that, it's just a file that just isn't being executed. It's not in the web path. It's just sort of dead code, which is normally a bad thing, trying to remove dead code. Here we're inserting dead code. So those are cool because when those go out, they should do nothing. I can tell you sometimes they do something. You think you don't necessarily even know the paths of your own code. And it's a really illuminating thing. You learn as a developer, you do this, you learn, oh yeah, this actually is super dark. Like this does absolutely nothing. But it takes a while to learn that actually because we're so used to like, for me, it's the iteration cycle of coding is so fast. You just keep going and going and going and going and going. It's like, oh wow, now I got to push out all this code. And you learn that like doing it smaller and doing this incremental approach actually is better. But it's a learned behavior. It's definitely not natural to me. And I just, my 64-bit thing, I started saying change, and then, oh, it didn't work. I have to undo all of it and just sort of figure it all out. So it takes a while to do this. And the key to break that cycle is pushing out code quick. It's easy and fast. You can do that, and it's fine. Anyway, so the other thing is, now that you've got your code out, it's on mainline or trunk or however you want to describe it, other people can see it easily. There's a lot of techniques for branching and source control, and that's a whole religious debate. But the thing is, if it's on trunk, everyone can see it easily. They don't have to check out another branch. They don't have to do anything. It's there. It's easy. They just do up, and they got all their new stuff. That's just one little barrier you just remove from other people looking at your code. That's actually really useful. So we've pushed out our bugs. We've pushed out all sort of the dead code. Time to actually start doing something. And this is previous company I did this. We did a ramp up by putting it out on one machine and seeing what exploded. Etsy does it a little differently where it's sort of built in. A little different, they have a different sort of system. But either way, the idea is you want to push the change out to a very small number of machines or people and see what happens. So Etsy, basically, if you're launching a new feature, you've pushed out all this code, but let's say, to make it easy, it's some new URL or something like that. Or you have your dispatcher or router or something. You just actually write that off. You go like, if false, do new code. Okay, that's completely dark. But maybe you do, if user ID, modulo 100 is 1, let's do this new feature. So you get like 1% of the people using the new feature. And you got your graphs now, so you can see what happens. And it's like, okay, the site didn't drop. Let's just push a config file out and make it 2%, 10%, 100%. And basically this technique, which is way too short to really describe how it all works in practice, is used by almost every large web property out there. Certainly Twitter, right behind me, does. What's funny, if you ask your friends, at Etsy, like, understand why does Etsy push this feature out and I don't have it yet? I don't know of any other sites that do this. Actually, every site does it. They just don't know it. So making the system to do this, it could be machines, could be people, really important. And certainly push it out internally first. On production, but only your employees can use it. Get real feedback in there. The nice thing is if you do find a problem, this also gives leeway, some time for the security guys to catch up. They now are able to actually test the code in production live. And it's at 1%. Okay, yeah, maybe there's a flaw out there. 1%, not really the end of the world. Not too worried about a mass exploit happening on 1% of the code. Most attackers won't even know it exists. Because most of the people in the company won't know it exists either. And the other thing is, if there's a problem, you just ramp it down. You push that config file out, off, and start over, figure out what's going on. And there's been a lot of really complicated features where we've actually had to ramp up and ramp down. It didn't quite work as expected, but we've really narrowed the scope down to the impact. OK, so, ooh, look at this. Take 8, take 8. OK. Take 9. So, you know, you're going to get burned when you start building out this infrastructure, but I could describe all of it, but it sort of leads itself. You know, you want dev to be close to prod. You want fast testing. You want to eliminate stupid bugs by, you know, on that commit step, static analysis. We just heard, I think, what Brakeman just before. You know, at Etsy we did PHP for hip hop. I'm forgetting what I worked on. There's static analysis for every language out there. And if you make it a post-commit hook, however you want to do it, or pre-commit hook, it catches bugs before they go to prod. Like that's maybe even before security, getting that static analysis step in place, super important. Because once you have that in place, you can start leveraging that infrastructure for security tests too. So once you have this thing like, hey, there's a pre-commit hook, there's a place to do stuff, one, it's going to be easy sell to your boss because you're fixing bugs. You're actually allowing developers to fix bugs. On top of that, now you got a place to insert your stuff. Hey, why is that guy all of a sudden using crypto functions? Maybe it needs a review. And true story, we found one. PHP with its lovely loose syntax. Cryptography, third argument, secret key, didn't exist. Who knows what's happening? But anyway, it's like these are things we were able to catch because we started implementing some stack analysis checks. And you really want to move all this stuff as close to the developer as possible. Let them be self-service. Then finally, that's great. It's just one person pushing out code. How do you roll that out to like a team of like 20 people and stuff? And you need a way of coordinating releases. And it is amazing when you actually get your developers talking. They can self-organize this pretty well. And it's actually good for them to be talking about what's going live, and what pieces are going live. And Etsy's, I think now it's got to be like 100 people self-organizing the releases. Certainly product or feature releases are more coordinated because there might be PR campaigns or marketing stuff or customer service issues. But in the day-to-day role, no one's supervising. Because people get in line, they talk, like, hey, what's your code doing? OK, there's no overlap. And we're scaling about 100 people. At some point, it's not going to work. We're going to need to separate out stuff. But 100 people is pretty big. And you don't actually need someone managing it. Certainly, it will take a little while to get the flow working, especially in a new organization, people learning to work together. But that's worth doing. And again, like conventions need to match your risk level. And again, at least developers are thinking about releases now. As before, they didn't even know when it goes out. I mean, you go ask your developers, hey, when did that piece of code go out? They're like, I don't know. They're certainly not going to care about security. They don't even know if their code is live or not, right? I don't think so. So look, mistakes are going to happen. We know mistakes happen. We know mistakes happen in any development methodology you pick. You think I'm full of crap? Awesome. But learning from the mistakes, really important. System mistakes are really complicated. They normally don't have easy answers. And almost never is the problem due to maliciousness. Occasionally, it might be incompetence. But most of the time, it's like, oh, I actually didn't know how that worked, because no one knew how it worked. All right, so then the whole point of doing postmortems and root cause and all this other good stuff is it's not to point fingers at people. It's like, how can we change the environment so this mistake doesn't happen again? That's maybe a little subtle. Postmortems aren't really about people. Why did you do that? It's like, how can we catch you from doing that again? Like, why did you think that was a good idea? Oh, because, well, maybe we should, make this check that doesn't do that. Like, why are we, you shouldn't be doing that. Like, let's make a check so that doesn't happen. I'm trying to give a really good example, but certainly, like, one just recently in my new job is, hey, you made a change to production. Did you get that reviewed with anyone? It's like, oh, no, I just did it. It's like, oh, well, hey, let's make a rule here. Make a change to production. Like, just have someone else double check you. It was the classic, SQL mistake, in this particular case I'm thinking of, which I've personally done, is, oh, I thought I deleted one record, and instead I just deleted the entire table. You know, like that. It's like when this is like my first day on the job, and it's like, wow, like I have so lived that. And because SQL, it's like literally one character, right? You're one character away from like, you know, same with production, you know, RM-star and all that other good stuff. So, you know, so how can you make rules and processes that like protect people from making the same mistake twice? Okay. So a lot of dull slides, but what that's you can't tell it's his Atlas's butt right there. It's really a good slide. Yeah. Yeah, that's right. All right, you're like, okay, Nick, those rules are great, but what about that guy? That guy pushes code at 3 in the morning. What are we going to do with him? And it turns out, well, one, convention, not contract. If you really have like a cowboy shop where people are doing that, okay, maybe you got a little personnel issue. But really, most of the time, the guy's like, I woke up, I'm trying to get some stuff done. It's quiet. There's no one in line to push out code. I'm not saying you can't do that, but you need some process around that. You know, let your ops team know. Let the security team know you're doing stuff. It's really about courtesy and respect. The guy who pushed at 3 in the morning, I bet you know who I'm talking about, Zane. You can guess. Yeah. He didn't think it was a bad idea. He didn't know because code going to production is this I don't give a shit process, right? Like, I don't know, it goes out of production, something happens. He doesn't even know if people's pagers go off. You know, like, he didn't know that. Like, that's amazing. Like, how do you not know that? But he didn't. Because the developers have been trained not to care about what happens in production, right? So it makes total sense to him. So it's like, you know, off-hour exceptions, you know, you inform people, but it's like, you know, actually it turns out, let me tell you, when Betsy comes in and talks to you about you push code at 3 in the morning, you learn pretty quick you're not going to do that again. You know, like, it sorts itself out really quick, really fast when the ops guys like beat down on you. Like, it happens fine. Code reviews. Yep, go do them. Didn't say anything about what I did here. It precludes code reviews. Absolutely go do code reviews. They should be easier and faster because they're smaller. You know, at Etsy, there's a lot of different techniques on it. Some people did every code review. Every push needed code review. Every change needed code review. Other groups had a little more flexibility in it. Good idea, bad idea. Up to you to decide that. Continuous deployment does not preclude code reviews at all. And in fact, they're easier to do because they're on trunk. You don't necessarily need to do all sorts of fancy tools and diffs and what's the name of that branch? It's on head. Security reviews, same thing. Go do them. Again, integrating with your flow is, you know, that's very particular to your organization. But there's nothing about continuous deployment that says you can't do them or can't work on them. So I don't know what to tell you on that. It's like, do them. Agile methods. Hard to understand. People ask me, I was like, what about, how's this different than Agile? And it's like everyone has defined Agile differently, so it's a bit tough to figure out what's going on. Frequently, the Agile methods are more about product spec and customer satisfaction, at least from what I gather. So they're a little less about the technical side of like code flowing through. So you can do Agile methods, but code can still sort of pool up waiting to go to production. So you can integrate the two, I think, pretty easily, but maybe slightly different. And finally, not quite finally, what about customer service? They freak out about changes. You know, B-sides, someone asked me about this. Most changes don't actually do anything. So customer service doesn't freak out, or they shouldn't do anything. And again, feature launches, you coordinate. So it's no big deal. So getting close to the end here, so why did I tell you all this? And I think I've already given you the punchline. It's just a random picture. There's no real. Don't read too much into this. You know, that engineer didn't push code who was afraid to hit the deploy button is now actually sensitized to operations, development, and security. And a lot of engineers are completely annoyed by security stuff because it's a huge pain in the ass to fix. It's a pain in the ass to fix. OK, I made my change. I'll wait a month, see what it does. Talk to you later. You know, the feedback loop's completely broken. So getting this going, oh, here's my slide, my pretty slide of Bryant Park at night. The other thing is security fixes go out fast. And you know they can go out fast because they happen every day already. It's not like, oh, well, you need a security fix. Well, I don't know, the QA guy's not really available today, and the release guy, blah, blah, blah. It's like, no, it just goes out. And that's really useful and important, because when you're under attack and need to close a hole, knowing things can go out in a sane manner is really important. It's just really important. And the nice thing is, once you build out all this stuff for deployment, you can now repurpose it for other stuff. You just heard the Twitter guys talk, lots of stuff there. How can you instrument security stuff in the development process now? And attack detection, vulnerability prevention. Zane and myself have done a bunch of things showing details on it. Feel free to go check out these prezos. And the other thing is, instead of now just going whack-a-mole, 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 you got a little more time now, because the release cycle's faster and easier, and you're a little more responsive, that you can actually work on being sort of more of an in-house consultancy. Engineers are now receptive to what you're hearing, what you're saying, because they're empowered to actually make changes. And that's it's a tough one to sort of get through. Running quickly here, sort of when you, at the full expression of this, new roles, less silos, developers work with operations, QAs make systems to empower developers and security people to do testing. Release guys, now instead of being the guy who does some magic, RPM, Deb, whatever, are making tools to push code to production. And security guys move from the annoying team in that other room to being in-house consultancy, security engineering, secure by default, and detection. And when you enable developers to be empowered, it turns out they're actually really interested in security. They just didn't have time to care. And so it's like, people actually go, hey, I don't quite know if I'm doing this correct or not. Like, developers will start asking. And it's really interesting. All right, I'm running way out of time here. Continuous deployment only for websites. I'm going to skip this. Wine robot at the airport, continuous deployment, good joke. Let me just sort of go through the edge here. So what now? OK, this is sort of really important. How many people are actually in the development organization? Yeah, that's good. OK, cool. Next time you go to the OWASP thing, bring someone else who isn't in security with you. Just make the hustle for it. Once developers start seeing it, they actually are interested in it. And what I'm concerned about is so many of the security conferences, as an OWASP one in New York, how many people in a development organization? About the same number of people? 3 people. Wow, I mean, we're never going to get ahead that way. We've got to get other people involved and gluing them in. And security is weird because it bridges all these different gaps, yet technical. It's not product, which might also branch this. So you're really in a good position, I think, to make change, because you have sort of like the magic card. Breach happens, security problem. I need to patch fast, right? You need to patch fast, right? So that isn't controversial, but in order to patch fast can cause this huge cascade of interesting things. So start with the deploy button. Get that going. Whoever is working on that deployment system is some guy typing stuff in a script. It can be automated. It's not magic. It's probably like 50 lines of bash code or something like that. Button, maybe deploy script. OK, something like that. Once you get this going, it is going to change your secure software development lifecycle. It really is going to change how you operate. And not only that, the job becomes a lot more interesting. You can focus on a lot more interesting stuff. So continuous deployment, you want it. Thank you. Deploy all the codes. And here's the slides. There's me. Thank you, Etsy, for sponsoring my trip. I'll be happy to take questions.